Question number 1. If A is the point -5, -2 and B is the point -2, 4, then the gradient of AB is... Well, first thing we want to do is note down the points. So -5, -2. So make that x1 and y1. And the other point, -2, 4, that's x2 and y2. So to find the gradient, we just substitute these into the gradient formula. So m equals y2 take away y1 over x2 take away x1. Substituting in the correct values. On the top line it's 4 take away -2, and on the bottom line x2, which is -2, take away x1, which is -5. So just moving this up a little bit. That then gives us on the top line 4 plus 2 over -2 plus 5, which gives us 4 plus 2 is 6 over -2 plus 5, which is 3, and 6 divided by 3 is equal to 2. So the gradient equals 2, which means the correct answer is answer D. Question number 2. We're asked the derivative of 1 over 2x cubed. So first thing we'll do is we'll just write this f of x equals 1 over 2x cubed. To differentiate this, we need to first prepare it for differentiation, which means the x cubed term has to be brought onto the top line, which means it will be x to the power -3 over 2. What that actually means is a half x to the -3. What we want to do now is differentiate this. So if we move this up a little bit and write f dashed of x to show that it's been differentiated, then it's -3 multiplied by a half x to the power, and subtract 1 from the power gives us -4. -3 times a half is -3 over 2 x to the power -4. What we want to do now is make sure our x to the power -4 finishes up with a positive power. So that's -3 over, and move x onto the bottom line with the 2 x to the power of 4. So looking at our answers, that corresponds to answer B, -3 over 2x to the power 4. Question number 3. The limit of the sequence defined by the recurrence relation un plus 1 equals 0.25 un plus 12. So the first thing we should do is identify A and B. Our recurrence relation limit formula is L equals B divided by 1 minus A. So substituting in our values, that's 12 divided by 1 minus 0.25. So 12 divided by 1 minus 0.25 is 12 divided by 0.75. So the challenge at this point is how to do 12 divided by 0.75 without a calculator. Now there is a few different ways of doing it. What we'll think about is 0.75 as a fraction. 0.75 is 3/4. So what we actually have here is 12 divided by 3/4. And that can be written out as 12 divided by 3/4. To do this, we change it to a multiplication and flip the fraction upside down. So 12 multiplied by 4 over 3. So that's the same as 12 over 1 times 4 over 3. On the top, 12 times 4 is 48, and on the bottom, 1 times 3 is 3. We then have 48 divided by 3, and 48 divided by 3 is 16. So our limit is 16, which corresponds with answer C. Question number 4. The rate of change of the function f of x equals 3x squared when x equals 3 is. So first of all, rate of change is the important thing here. When we see that, we should know to differentiate. So f of x equals 3x squared is what we start with. Differentiating gives us 2 times 3x to the power of, take 1 away from the 2, gives us 1, which is just 3x, which then gives us 6x. We're interested when x equals 3, so that's 6 times 3, which is 18. And that answer is answer B. Question number 5. Which graph is most likely to be that of the function f of x equals x squared bracket x plus 3? So we have 4 different graphs here. The first thing we have to do is determine where the roots of the graph are. So that's where it cuts the x-axis or touches the x-axis, and that occurs when y equals 0 or when f of x equals 0. So we have x squared plus 3x, plus 3, sorry, and we're going to make it equal to 0 in order to find out the roots. Now, to do that, we don't really need to do anything here because it's already factorised for us. What that means is either x squared equals 0 or x plus 3 equals 0. This one, x squared equals 0, means x equals 0. The other one is x plus 3 equals 0, so that means x equals negative 3. So the roots of our graph have to be at 0 and negative 3. So graph A has roots at 0 and at negative 3, so that's a possibility. And graph C has roots at 0 and negative 3, so that one's a possibility. So it means that we can disregard B and we can disregard D. Now, what we need to do now is we need to take one of the graphs and substitute in the other point that we're given. So we have another point, we'll have a look at graph C. We have another point on the graph, and on graph C, it's the point minus 2, minus 4. So minus 2, minus 4. That means the x value and the y value on the curve are x is minus 2, y is minus 4. If that point represents a point on our curve, so in other words, if C is the correct one, then if we substitute it back into the original equation, it should work out. So we have f of x or y equals x squared bracket x plus 3. So what we're going to do is we're going to substitute our value of x equals negative 2 in here. So y equals negative 2 squared bracket negative 2 plus 3. So if we do that, we get y equals negative 2 squared is 4, multiplied by minus 2 plus 3, which is 1, and 4 times 1 is 4. That means we were expecting the y value to be 4 when x equals negative 2. So the point on graph C gave us an x value of minus 4 when x was equal to negative 2, so that means C can't be the right answer. Which one is the right answer? Well, we got y equals 4 when x was equal to negative 2, and that sits correctly with the first one, which means answer A is the correct answer this time. Question number 6. In the diagram A, B, C, here, A, B and C are the points negative 5, 2, this point here. B is negative 3, negative 2, and C is the point 4, negative 1. Part A asks us to find the equation of the line through C, which is parallel to the line AB. So we've got the point C here. We want to find a line that's passing through this point, which is parallel to this line here, AB. That means if we were to draw it on, it would probably look a little bit like this. Part B of the question asks us to find the equation of the line perpendicular to BC, which passes through the point A. So first of all, I'll extend BC Okay, we're looking for a line which is perpendicular to line BC, which passes through A. So that would be a line that would look something like this in order to get a right angle here. Then part C asks us to find the coordinates of T, the point of intersection of the two lines. Now, the way the diagram is here, it's impossible to draw that. The two lines here, as you can see, are sloping upwards. If you imagine extending these two lines, then eventually somewhere up off the page they would meet. Okay, so on this diagram it's impossible to put the meeting point down, but the point T, the point of intersection of two lines, will be up at the top somewhere. Now, this question is peculiar in the fact that it doesn't ask us to work out one of the normal lines you get with these triangles. It doesn't ask for the altitude, the median, or the perpendicular bisector. So the one we'll look at first of all is part A, obviously. Find the equation of the line through C, which is parallel to the line AB. So in order to find the equation of a line, we need to know two things each time, and that is what the gradient of the line is and some point on the line. We know a point on the line already, this point C here. So C is the point 4 minus 1, so we'll fill this in, 4 minus 1. And M, the gradient of the line, well, we're told that this line that we're looking for is parallel to the line AB, which is this one on the side of the triangle, which means that we can work out the gradient of this line. It will be the same as the one we're looking for. Fortunately, we know points A and B, which means we can work out the gradient of AB fairly easily. So we'll do that now. So we'll give ourselves a little bit of space to work. So first of all, what we know is we know point A is the point negative 5, 2, and B is the point negative 3, negative 2. To work out the gradient of that line, we use our gradient formula. M equals y2 minus y1 over x2 minus x1. Substituting in the values, we have M equals, and we'll make this x1 and y1, x2 and y2. So y2 is negative 2, take away y1, which is 2, over x2, which is negative 3, take away x1, which is negative 5. So that gives us negative 2 take away 2, which is negative 4, and negative 3 take away negative 5, which is negative 3, plus 5, which is 2. That gives us negative 4 over 2, which is negative 2. So that means the gradient of the line AB is negative 2, which means that the gradient of the line we're looking for is also negative 2. So we'll put that back in up here. So the one we're looking for, the gradient is negative 2 also, because it's parallel. What we need to do now is take our point and our gradient and put them into the equation of a straight line formula. So we'll give ourselves a bit of room again. We'll do it over here. So the equation of a straight line is given by y minus b equals m bracket x minus a. And that's y take away b, and b from our point up here is negative 1, so that's y take away negative 1 equals our gradient, which was negative 2, bracket x minus a, which was 4. So that's y plus 1 equals negative 2 times x, which is negative 2x, negative 2 times negative 4, which is plus 8. Collecting all of this to the one side gives us y plus 2x plus 1 minus 8 equals 0, which means y plus 2x plus 1 minus 8 is minus 7 equals 0. And that's the equation of the line through point C. So looking back at our diagram again, part B asks us to find the equation of the line perpendicular to BC, which passes through point A, which is this point here. So we'll remind ourselves what that was again. So if we extend the line BC outwards and then draw a line through A, which is perpendicular, then we're looking for the line here. So in order to find the equation of a straight line, again, we'll remind ourselves what we need. It is m, the gradient of that line, and a point on the line. So as we can see, we know a point on the line. We know the point -5, 2. So we'll put that one in here. And the next thing we need to know is the gradient of the line. Now the gradient of the line, if we wanted to use the gradient formula, we would need 2 points in the line. So looking along the line here, you can see that we only know point A. What we do know, however, is that it's perpendicular to this line BC, which means that we can work out the gradient of BC using the gradient formula. We can then just flip it upside down and change the sign to find the gradient of the line that we are looking for. So that's what we're going to do. We're going to use points B and C in order to work out the gradient of that line. So again, we'll give ourselves some space. Move this up here. The gradient we're trying to find is the gradient of BC. So the points BC, we'll write them down. B is -3, -2, and C is the point 4, -1. So that's our x1 and y1 value, and x2 and y2. So to work out the gradient of that line, use the gradient formula. M equals y2 minus y1 over x2 minus x1. Substituting in our values, y2 is -1, take away y1, let's take away -2, over x2, which is 4, take away x1, so let's take away -3. So that gives us -1 plus 2, which is 1, and then 4 plus 3, which is 7. So that means the gradient of the line BC is 1 over 7, which means the gradient of the line we are looking for, this one here, is this flipped upside down with the sign changed. So the M, the perpendicular gradient, is -7 over 1, which is just equal to -7. So what that gives us then, that gives us our gradient of our red line. We now know that that is something we can fill in here. So that is -7. We now have a gradient and a point to use in our straight line formula. So substituting those things in. So again, just giving ourselves a little bit of space. We'll do this over here. That gives us y minus b equals m bracket x minus a. So that's y take away b, and b is 2, equals m, which is -7, bracket x minus a, so that's x take away -5. So y take away 2 equals -7, bracket x plus 5, which is y minus 2 equals -7x, -5 times 7 is 35. So rearranging this and collecting everything to the one side gives us y plus 7x minus 2 plus 35 equals 0. So y plus 7x minus 32 plus 35 is plus 33. That's equal to 0, and that's the equation of our line. Part C on this question asks us to find the coordinates of T, the point of intersection of the two lines. So the first thing we're going to do is write the two equations of the lines down. That's what we worked out in parts A and B. So the equation of the first line we worked out is y plus 2x minus 7 equals 0. And in the second part, the second equation was y plus 7x plus 33 equals 0. In order to find the point of intersection, we need to solve these simultaneously by the traditional method, or substitute one into the other, or if we can, make one equation equal to the other. So we'll choose the latter method. So the first one, the blue one, can be rewritten as y equals negative 2x plus 7. And the red one, the same sort of way, we can write it as y equals negative 7x minus 33. Now, both equations are now in the form y equals. So if they're both y equals, then that means we can make the first equation equal to the second equation. So that's minus 2x plus 7 equals minus 7x take away 33. So now we have an equation with x's in it only, which means we can rearrange in order to solve for x. So we have minus 2x on this side. If we bring minus 7x onto that side, it becomes plus 7x. On the other side, we already have negative 33, and if we take plus 7 onto that side, it then becomes negative 7. So we have negative 2x plus 7x, which is 5x, and negative 33 take away 7, which is negative 40. So 5x equals negative 40, which means x is negative 40 divided by 5, which means x equals negative 8. So we have our x value for our point of intersection. What we need now is the y value. So we take our negative 8 and we substitute it back into one of the equations. So we'll just substitute it into this one here. So we'll write that down. Y equals negative 2x plus 7. We now know x is equal to negative 8, so y equals negative 2 times negative 8 plus 7. That means y equals negative 2 times negative 8 is 16. And we have plus 7. And 16 plus 7 is 23. That then gives us the coordinates of our point T, the point of intersection of the two lines. The point T is x value negative 8 and y value 23, the point of intersection. Question number 7. Two functions are defined on suitable domains and are given as f of x equals 3 minus x and g of x equals x minus 3. Part A asks us to find an expression in its simplest form for g of f of x. So that means we're going to substitute the f function into the g function. So in order to do that, what we do is we take our f function and we substitute it in anywhere we see x on the g function. So we write that down, g of f of x. So putting down our g function, it was x minus 3, but we're going to replace the x with 3 minus x from the f function, take away 3. So that's 3 take away x minus 3, so we can write that without the brackets. 3 take away 3 means the 3's cancel out, which leaves us with negative x. So part A, g of f of x is negative x. Part B in this question asks us to show that g of f of x, that's the thing we just worked out, negative x, if we take away f of g of x, then the answer should be negative 6. So what that means is we need to work out what f of g of x equals. So what that means this time is substituting the g function into the f function. So that means replacing x in the f function with the g function. So we'll do that here. So f of g of x, so the f function is 3 take away x, but we're going to replace the x with the g function, which is x minus 3. So 3 take away x minus 3, we'll remove the brackets, which gives us 3 take away x, and then the minus sign and the other minus sign make that plus 3. What that means is 3 take away x plus 3 plus 3 is 6, so it's 6 minus x. So f of g of x is 6 minus x. That means we now know both of the composite functions that we're looking for up here. We know that g of f of x, first of all, is negative x. And we know that f of g of x, the one we just worked out, is 6 minus x. So what we have to do now is subtract the second one from the first one. So that's minus x, take away this function. So we need to take away the whole lot. And hopefully when we do that, we will get negative 6. So we'll give ourselves a bit of space to do some working with that. So we have minus x, take away 6 minus x. So that's minus x minus 6, and then the two minus signs make a plus sign. So the minus x and the plus x cancel out, leaving us with negative 6. So we have shown that the left hand side equals the right hand side, so that means we have proved what we set out to. Question number 8. A recurrence relation is defined as un plus 1 equals a times un plus b, where a and b are constants. Part A says, given that u2 equals 14, u3 equals 9.2, and u4 equals 5.36, find the value of the constants a and b. So what we can do is we can use these values for u to set up a recurrence relation in this form. We have enough u values to set up two equations, and that's useful because if we have two unknowns, a and b, then in order to solve for a and b, we need to solve the equations simultaneously, which means we need 2. So we'll set up the first one. So the first thing we'll do is give ourselves a little bit of room. So the first one, we'll start off with u4. So u4 equals a times the previous one, which is u3, plus b. We know u4 is 5.36, so it's 5.36 equals a times u3, which is 9.2, plus b. That means that 5.36 equals 9.2a plus b. What we're going to do next is set up another one. So this time we'll start off with u3 equals. So it's a multiplied by the previous one, which is u2, plus b. u3 we know is 9.2, so it's 9.2 equals a multiplied by u2, and u2 is 14, plus b, which gives us 9.2 equals 14a plus b. So what we have now are two equations. 5.36 equals 9.2a plus b, and 9.2 equals 14a plus b. So what we're going to do next is look at solving those simultaneously. So again, we'll give ourselves a little bit of room. So we'll do that over here. So we'll write down the two equations. The first one is 5.36 equals 9.2a plus b, and the second one is 9.2 equals 14a plus b. So fortunately the b's at the end make this a fairly simple process. To cancel or eliminate the b's, we'll do the second equation, the one on the bottom, take away the one on the top. So b take away b on the top, first of all, leaves us with 0 on the end. Then 14a on the bottom, take away 9.2 on the top, gives us 4.8a on the bottom. And finally 9.2, take away 5.36 is 3.84. So we'll just write that the other way around to begin with. 4.8a equals 3.84, which means that a equals 3.84 divided by 4.8, and 3.84 divided by 4.8 is 0.8. So a equals 0.8. What we need to do now is take our 0.8a value and substitute it back into one of the original equations. So we'll take the a and we'll substitute it not into that one but into this one rather, this one up here. So giving ourselves a little bit of room, move this up. That then gives us 9.2 equals 14a plus b. That's 9.2 equals 14 times a, which is 0.8 plus b. So 9.2 equals 14 times 0.8, which is 11.2 plus b. So that means b is equal to 9.2. Take away 11.2 by rearranging, and 9.2 take away 11.2 gives us b equals negative 2. So we have our b value, b is negative 2, and our a value, which is 0.8. So going back to our question again, part A, we now know a is 0.8 and b is negative 2. Then part B of the question says, hence, explain why this reconciliation has a limit. So that's because of the value of a, that's in here. A is 0.8. A reconciliation is defined as having a limit if the value of a is in between -1 and 1. In this question, a works out to be 0.8. Therefore, it has a limit since this value is in between -1 and 1. Part C asks us to establish the value of u1. Now, normally we would do that by setting up a reconciliation with u1 at the beginning, but that means we would need to know u0 to put inside the reconciliation. So instead of that, we're going to set up a reconciliation with u2 at the beginning. So u2 equals a, which we now know is 0.8, multiplied by the previous one, which is u1, plus b, which is negative 2. So we already know u2, which means we can fill that in at the beginning. u2 is 14, so that means 14 equals 0.8 multiplied by u1 minus 2. So rearranging, we get 0.8 u1 equals 14 plus 2. So 0.8 u1 equals 16, which means that u1 is equal to 16 divided by 0.8. Now it's expected that you will be able to do this without a calculator, so that means we need to get rid of the decimal on the bottom line. So we can write this u1 equals, and then if we multiply by 10 on the top and the bottom, we get a 160 on the top divided by 0.8 times 10, which is just 8. So that's 160 divided by 8, and 160 divided by 8 is 20. So u1 is equal to 20. Question number 9. Find the equation of the tangent to the curve y equals x cubed minus 3x at the point where x equals 2. So we're asked to find the equation of the tangent. Now the first thing we should realise is that the tangent is a straight line, which means what we need is we need m, the gradient, and a point. So right now what we're told is that the point where we're looking for is x equals 2, which means we know part of our point already. That means we need to know our y value from our point so that we can fill it in here. And we get that by substituting x equals 2 back into our equation to find y. So we'll do that first. So writing down our equation that we have, it's y equals x cubed minus 3x. We know x is 2, so that's y equals 2 cubed minus 3 times x, which is 2. So that should be cubed. y equals 2 cubed, which is 8, minus 3 times 2, which is 6, which means y equals 8 take away 6, which is 2. So that means when x equals 2, y equals 2. What we need now is we need our gradient. Now, as soon as you mention the word gradient, you should be thinking of differentiating this thing here. So we'll give ourselves a little bit of room to do that. So first of all, writing down the original equation again, that's y equals x cubed minus 3x. So differentiating that, we get dy by dx equals 3x squared minus 3. So this thing here now represents the gradient. So 3x squared minus 3 is our gradient. We're interested in the gradient at a particular point. It's when x equals 2. So we substitute that in here, which gives us 3 times 2 squared minus 3, which is 3 times 2 squared, which is 3 times 4 minus 3. 3 times 4 is 12 minus 3. Moving that up a bit. 12 minus 3 is 9. So that means now we know our gradient is 9. So we can take that and fill it in up here at the top. So m equals 9. What we have now is we have the point in the gradient we need in order to write down the equation of the line. So again, giving ourselves a little bit of room, we'll do this over here. The formula for a straight line is y minus b equals m bracket x minus a. So substituting in a point 2, 2 is y minus 2 equals, and the gradient, substituting that in also, is 9 bracket x minus 2. So y take away 2 equals 9 times x, which is 9x, then 9 times 2, which is 18. Collecting that all to one side gives us y minus 9x minus 2 plus 18 equals 0. So that's y minus 9x minus 2 plus 18 is plus 16, and that equals 0. And that is the equation of a tangent at the point x equals 2. Question number 10. We're asked to express the function f of x equals 3x squared minus 6x plus 11 in the form p bracket x minus q all squared plus r. So we should recognise that this form is this one with completing the square. So to get it in this form, we need to complete the square, as we have just mentioned. So first of all, we'll write down the function that we have to begin with. It's 3x squared minus 6x plus 11. So what we need to do first of all is take out a common factor. So 3 outside the bracket, x squared minus 2x. Then the tricky bit is trying to force a common factor out when we have 11. So we need 11 over 3 inside to make that happen. Now, putting our square bracket down again, we have x squared minus 2x. Then we would expect it to say plus 1. Okay, so it doesn't say that, but that's what we would expect. We've added 1 in ourselves, which means if we add it in with one hand, we must subtract it with the other. Then not forgetting our plus 11 over 3. So this here is just a little separator line. It's not a number. Close our brackets. So 3 outside the bracket again. Put our square bracket in. What we need to do now is write this in the form of a perfect square. So that's another bracket, and then it's x minus 1 all squared. Then we have our thing over here at the side. Okay, so we could try and add that together at the moment, but that gives us more work than we need to do, and we'll see why that is in a moment. So minus 1 plus 11 over 3. So we need to remember that all of that is contained within this square bracket. Now, If we tried to add those things together, we would have had a little bit of hard work, whereas if we wait till after we've multiplied out by the 3 at the front, it will be much easier. So 3 times the bracket, first of all, just gives us 3 bracket x minus 1 squared. Then 3 times minus 1 is minus 3. And then 3 times 11 over 3 is just 11. That means we can now add together without any real difficulty. Oops, that's not plus, that's minus. So minus 1 squared, and then minus 3 plus 11 is plus 8. So we now have it in the form that was required, and that is the end of the question. Question 11. Part A, the point 125, k lies on the graph of y equals log x to the base 5. Find the value of k. So we'll tackle this part first. Okay, so we'll give ourselves a little space to work here. So first of all, we'll write down the equation we were given, which is y equals log x to the base 5. We are given a point 125, k, so 125, k, where x is 125 and y is k. So we substitute that in, we get k equals log of 125 to the base 5. If I now write that round the other way, log 125 to the base 5 equals k. Then using the technique shown before, the arrow technique, we should remember that that means 5 to the power of k equals 125, which means all we need to do now is determine what k needs to be in order to give us the right answer. So 5 times 5 is 25, and times by 5 again gives us 125, which means it's 5 to the power of 3, which means k equals 3. Part B of the question, the diagram shows part of the graph of y equals a to the power of x. State the value of a. So this one's actually fairly straightforward. We'll give ourselves a little bit of room here. So we have our equation, which is y equals a to the power of x. We have a point P, so that means the x value is 2, the y value is 9. Substituting that in, we get 9 equals a to the power of 2, or in other words, a squared equals 9. So if a squared equals 9, that means a equals the square root of 9, and the square root of 9 equals 3, remembering that we have to have a positive answer with logs. Question number 12. The diagram shows an open top box with a square base of x centimetres and height h centimetres. We're then told that the box had to be made from an 1,350 square centimetres card, which is the area of the card required. Part A show that in terms of x, the height of the box can be expressed as 1,350 minus x squared over 4x. So we're trying to show that h equals that. Then in part B it says show clearly that the volume of the box can be expressed as this one here. And then finally, part C, hence or otherwise find the value of x so that the volume of the box is a maximum, leaving your answer as a surd in its simplest form. And it asks us to justify the answer. So that means even if you can't do parts A and B, you take this thing and then you do part C using the same steps as usual. So we'll tackle each part at a time. First of all, part A, we need to show that the height equals 1350 minus x squared over 4x. So we'll give ourselves a little bit of room by moving this off to the side. So first of all, what we know is that our box is made up of 5 pieces of card altogether. If we think about the front face, then we have a piece of card which is x centimetres by h centimetres. Now we have 4 of them altogether because the front is the same as the back and so are the two sides. So whatever we get for the area of that, we need to multiply it by 4. So the area of a rectangle is the length times the breadth, which is x times h. And since we have 4 of them, that means the area of the sides and the front and the back in total is 4xh. What we also know is that the base of the box is a square. The length and the breadth is x centimetres by x centimetres. So once again, the area of a square or a rectangle is length times breadth, which is x times x here, which means x squared. That means our total area for the whole box is the 4 rectangular parts plus the base. So that's 4xh plus x squared. Now what we also know is we also know the area, the total area. We're told that it is 1,350. So that means we can substitute this in here also. We know that 1,350, the total area, is equal to 4xh plus x squared. Now we need to keep focus what we're trying to do here. What we're trying to do is we're trying to show that h equals this, which means what we're going to do with the thing we have now is we're going to rearrange it so that we have h, the subject of the formula. So the first way to do that is to begin by switching the sides round. So we'll make that 4xh plus x squared equals 1,350. We'll then move the plus x squared onto the other side, which gives us 4xh equals 1,350. Take away x squared. We want to find h on its own, so h would be 1,350. Take away x squared. And when 4x comes to the other side, it changes from times on this side to divide on the other side. So it gives us 1,350 minus x squared over 4x. And if we look back, what we're trying to show just that. So that means we have shown the first part. Part B asks us to show clearly that the volume of the box in terms of x can be expressed as this thing here. So what we know about the volume of a box is that we find it by working out the length times the breadth times the height. So the volume of this cuboid box is LBH, length times breadth times height. That means the volume is the length, which is x, multiplied by the breadth, which is x, multiplied by the height, which we now know is this thing here. So substituting that in here, we get 1350 minus x squared over 4x. And then close our bracket. So that then gives us v equals x times x is x squared times this thing, 1350, minus x squared over 4x. If we then multiply that out, we then get v equals, and this is like x squared over 1. So on the top line we get x squared multiplied by the top of the fraction, which is 1350 minus x squared. And on the bottom, 1 times 4x, which is 4x. What we can do now is we can cancel this x with one of the x's from the top line, moving this up a little to give us some space. That then gives us v equals, change colour, x bracket 1350 minus x squared, close bracket, over 4. Now that's almost what we're looking for. If we look back to what we were looking for, it's not quite in this form. We have over 4 here, and we need to remember that dividing something by 4 is the same as multiplying it by 1/4. So that means we can rewrite this as 1/4 multiplied by the thing in the top, which is x bracket 1350 minus x squared. So that is exactly what we were looking for. So just look back to see that. Okay, so that's exactly what we were looking for in here. Part C asks us, hence or otherwise, find the value of x so that the volume is a maximum, leaving your answer as a surd in its simplest form and justify your answer. So what we've got here is we've got our volume formula, which we have just shown. We want to find out where it's a maximum. So as soon as you think of that, you should be thinking that we're trying to find a stationary point. And to find a stationary point, we'll need to differentiate the thing we have here. So we'll do that over here. So try and give ourselves a little bit of space. So writing down what we have to begin with, it's v of x equals, and then it's 1/4 x bracket 1350 minus x squared, close bracket. So what we need to do first of all is prepare this for differentiation, which means we need to remove the bracket. So v of x equals 1/4 x times 1350, and then 1/4 x times x squared, which is 1/4 x cubed. So give ourselves a little bit more room. That means that v of x equals 1/4 x times 1350 is 1350 over 4x, take away 1/4 x cubed. Now it's ready to differentiate, so we can go ahead and do that. So v dashed of x equals, differentiating the first thing just means that the x part disappears, which leaves us with 1350 over 4. And take away then 3 times 1/4 x, subtract 1 from the power, makes it x squared. So that means we have 1350 over 4, take away 3 over 4 x squared. Now, we know when we differentiate what we are finding is the gradient, and since we are looking for a stationary point, we know that the gradient has to be equal to 0. So it's important you put that in here at this point. So what we'll do now is rearrange and try and solve this for x. So if we take negative 3/4 x squared to the other side, we get 1350 over 4 equals, and negative 3/4 x squared just changes to 3/4 x squared. So that can then be written as 1350 over 4 equals 3x squared over 4. Now the fractions are posing problems at the moment, but since both sides are over 4, then an easy thing to do is just multiply by 4 on both sides to remove the fractions. And as long as we do the same thing on both sides, that's fine. That leaves us with 1350 equals 3x squared. So writing that round the other way, we get 3x squared equals 1350. So that means x squared equals 1350 divided by 3. So we'll try and do that without using our calculator. So 1350 divided by 3. 3 into 1 doesn't go, so cross out the 1, carry it on to the 3. 3 into 13 goes 4 times, remainder 1, so carry that on. 3 into 15 goes 5 times, and then 3 into 0 is 0. So that means that x squared is equal to 450, which means x equals the square root of 450. Now the answer asks us to leave our, the question asks us to leave our answer as a surd in its simplest form. So if we want to do that, then we need to simplify the square root of 450. Now, I think the easiest thing to spot here is that the square root of 450 is the same as the square root of 9 times 50. I think that's the easiest one to spot straight away, which means x equals the square root of 9 times the square root of 50, which means x equals 3 times root 50. Now we can further simplify root 50. So x equals 3 times, and then root 50 is the same as 25 times 2 in our square root, which means x equals 3 times the square root of 25 times the square root of 2. The square root of 25 is 5, so that's 3 times 5 times root 2, which means our answer for x as a surd in its simplest form is 15 root 2. So this is the value of x, which gives our maximum value. We're asked to justify our answer, which means we need to show that this x value stationary point is a maximum, which means we need to use a nature table. So we'll move this up here, and give ourselves a bit of space. So on the top line of our nature table, we need a number before 15 root 2, and then a number after 15 root 2. Now, the square root of 2, if you think about it, it has to be less than 2 but more than 1. So if we're looking for a number bigger than 15 root 2, we could choose 15 times 2, which is 30. So in here, we'll take a value of 30 for 1 being bigger. And if we want a value smaller than 15 root 2, then an easy one to use is 0. So setting up our table, on the second row of our table, we have our v dashed x, which is the derivative, which will indicate the gradient, and lastly the slope. So we already know 15 root 2 is the stationary point, so we can fill 0 in there straight away. In order to find the derivative in each side of this, we need to first of all substitute in 0. So our differentiated formula, we'll write it down under here to remind us what it is, was v dashed of x equals 1350 over 4, take away 3/4 x squared. So first of all, if we substitute 0 in here, well, putting 0 in where the x squared term will make that 0, which means this bit completely becomes 0, which means we're left with 1350 over 4, take away 0. Now quite clearly that is going to be a positive answer. If we then substitute in 30, we'll give ourselves a little bit of room for that. That gives us 1350 over 4, take away 3/4 times 30 squared. So 30 squared is 900, so that's 1350 over 4, take away 3/4 times 900. That's 1350 over 4, take away 3 times 900 over 4, which is 1350 over 4, take away 3 times 900 is 2700 over 4, and quite clearly we have one fraction take away a bigger fraction, which means our answer is going to be negative here. So that means we can say that this value in here is negative. That gives our curve sloping upwards, and then flat, and then downwards, which indicates a maximum, which you must write in. So this is a maximum. So we've now justified our answer, and that is the end of the question.